This is section 10.1.5. We're going to take a look at cosecant and secant functions. So we're going to graph cosecant and secant functions. Now these are the parent graphs for cosecant and secant. Now if you notice that little dotted line in the back, that's the parent graph for sine, and then here's the parent graph for cosine. So that's cosine, and then that's sine. Essentially, for us to graph secant and cosecant, we do everything the same. We graph our sine or cosine graph, but instead of shading it in, wherever it crosses the center line become asymptotes. And then wherever the peak is of our amplitude, we get these like parabola looking things. They're not parabolas, but they're parabola looking things. We just draw those. So all we do is change the shape, but the process in finding it is all the same. Now, just for a few properties, just to emphasize, the domain is not negative infinity to positive infinity because it has these asymptotes. So both cosecant and secant have these asymptotes where it crosses the center line. It's still continuous and smooth on its domain. It still has the properties of being even for secant and odd for cosecant. It still has a period of 2 pi. So that's why our starting value is still, we put our whatever's inside our function between 0 and 2 pi because it still has that natural period. So let's just look at one. So I know it says secant. We have our amplitude of 2. It says secant. So because it says secant, I want to think of my cosine parent graph because they're reciprocals of each other. And so I can take that theta minus pi halves, put that between my original starting value and my original ending value, add pi halves to everything. So 2 pi plus pi halves, right? You have to find the common denominator, 2 over 2, 4 plus 1 is 5. So now we can do our box thing. But remember, you can, however you want to draw that, all I'm doing is just finding x values. So this is my new starting x value, pi halves, my new ending x value, which is 5 pi over 2. Add them together, divide by 2, so you get 3 pi over 2. Add them together, divide by 2, you get 2 pi over 2, and then 4 pi over 2. So all of this looks like it's going up and down by pi halves. There's no vertical shift, so my center line is still at 0. So now I just go through and I just draw in what my cosine graph would be. Right? I followed it. Starts at the amplitude, crosses, goes below, crosses, starts at the amplitude. Starts at the amplitude, crosses, goes below, crosses, goes back to the amplitude. At where it crosses the center line, we draw asymptotes. So I can get rid of those little dots, make it look a little cleaner. And then at the peaks, we draw these parabola looking things. And that's a graph of our secant. Let's do another one. So I know that there's a reflection. I know because it's cosecant, it's sine. So drawing my sine parent graph. I know I have a vertical shift of 3. So I can take the theta over 2, put that between 0 and 2 pi, multiply everything by 2. Starts at 0, ends at 4 pi. add them together, divide by 2, add them together, divide by 2, add them together, divide by 2. It's going up and down by pi. So I can label that. We have 0, we have pi, 2 pi, 3 pi, and 4 pi. My vertical shift, so my center line moved up 3 spaces, right? So that shifted up 3. And so now at the first value, it crosses the center line. And then now, because of that negative reflection, that got reflected down, that got reflected up. So then it goes down, crosses, goes above, and crosses. So now, to change it into the cosecant graph, where it crosses the center line, you draw in your vertical asymptotes. Then at the amplitude, we draw the parabola-looking things, but remember they're not parabolas, they just look like parabolas. And I can clean it up, I can get rid of those dots. And there's our cosecant graph. So what did we learn today? We learned how to graph secant and cosecant graphs. The way that we graph them is by pretending it's sine or cosine, and then at the very end, instead of drawing the sine or cosine shape, you draw the cosecant or secant shape, which is where it crosses the center line, you draw in asymptotes, and then at the peaks, where the amplitude is, you draw parabola-looking things. This does conclude our lesson. If you have any other questions, please leave them in the comments.